And thank you all very much for coming to the 11th of our Gresham lectures on the environment on the topic of net zero. And in this lecture, so over this course, this is the 5th of the lectures this year, where we're talking about the overall theme is when net zero, so sort of how fast should we be thinking about stopping climate change. And in the last couple of lectures, we talked about impact of climate change on extreme weather, and then in the most recent one, global tipping points, and the kind of things that people typically worry about and ask me about in terms of am I concerned about the impact of climate change on this, that, and the other. And I just sort of start off by explaining this lecture is about what I really am concerned about. A long time ago, Mark Linus, an author based in Oxford, somebody I've got to know quite well, published a book called 6 Degrees, and it was all about the bad things that happened as you progressed up through the degrees as the world warmed. And I remember at the time, students asking me, I was on a panel with Mark, was I worried about 6 degrees? And the honest answer was, not really. Not because I don't think 6 degrees of warming would be really bad, but because I just think it's entirely moot. I don't think we'll get there. I think the things that worry me about climate change are not only the frictions that it's likely to induce in the world as we sort of if we carry on as we're going and steam past 2 degrees, and also the potential destabilisation of more panic-stricken measures that might be taken to stop it. And those are the two things I want to talk about today. So both the risks of just allowing warming to continue, the geopolitical risks of measures like turning down the sun, so solar geoengineering. And finally, probably more controversially for many people, I also think many people agree that solar geoengineering is a bad idea because of its potential impact on geopolitics. But I think we have to look at all climate policies through the same lens. We have to ask ourselves, of all the measures people are proposing to take on climate change, which are the ones that run the risk of actually destabilizing the world? Because one of the things we've learned, if not learned anything over the past few years, we're rather better at killing each other than Mother Nature is. So I think one of the things that I think we all need to think about is, if it's true that, and I believe it is true, that the risks, the geopolitical risks of some climate solutions may actually not be worth it, and I think solar geoengineering is one of them that's just not worth the risk, then the corollary of that must be that there must be some level of warming that it's actually worth settling for to avoid the potential conflict of eliminating it. And that's where people get, oh, really? You're sort of saying, but there must be a payoff, there must be a trade-off there. And I think we do need to think about that. And that's the sort of thing I want to talk about in this lecture, and in particular sort of more precipitate scenarios for phasing out fossil fuels border on what you might call social geoengineering, which would be potentially very challenging and destabilizing, but for the world. And by the way, not just for the world, I think we are entering a phase where, in Britain, climate change is, for whatever reason, becoming an increasingly divisive issue, and people are pushing that, and that's the Reform Party on the line there, I'm sure. So we are facing the challenge of this becoming a much more divisive issue here as well. So the overarching point of this lecture, there's sort of three ways in which climate change could trigger a global conflict. We have unmitigated impact, so we just let it go, and I'll talk about that. We'll talk about solar geoengineering, attempting to control the weather, and we'll talk about the potential side effects of poor mitigation policies. That's probably the most controversial question. So as far as the geopolitical consequences of just letting the world warm, I thought I'd start from this very well-known diagram from the Intergovernmental Panel on Climate Change. This is the way they represent the risks of different levels of warming. And by and large, warming does, the physical risks of climate change do scale with the amount of warming we've got. And the transition here from sort of yellow to red is from moderate risk to high risk and so on. And you can see, by the way, that the narrow columns are from the fifth assessment report. That was back in 2014. The broader columns are from the latest assessment. And you'll notice that one of the shifts in the climate community and research community has been to bring forward the point at which we think there's higher risks to the various reasons of concern that the IPCC has identified. People do often ask me, is it worse than we thought? And the answer at the sort of global level, at the kind of modeling the overall climate response to rising greenhouse gases, the kind of thing that I do, the answer is not really. It's sort of evolving pretty much exactly as we expected. But when it comes to the impacts of the warming we're seeing, we're tending to see these impacts appearing earlier, and each successive revision of the Intergovernmental Panel on Climate Change reports has tended to bring forward the points at which they're saying there's high risks to different systems. And they classify this in these various ways. And so you'll notice there's 5 reasons for concern they talk about. Unique and threatened systems, that's the Arctic ecosystems or coral reefs, ecosystems that are particularly impacted by climate change. Extreme weather, we know what that is. Distribution of impacts, we'll come back to that. Global aggregate impacts are when we're talking about, say, the impact on the entire world economy. So what's the overall aggregate impact of climate change on the world economy? And large-scale singular events are the sort of things we were talking about in the last lecture. Shutdown of the thermohaline circulation, collapse of the West Antarctic ice sheet, that sort of thing. So generally speaking, if you sort of ask what people think they're concerned about in climate change, it's, the unique and threatened systems, dying polar bears. If you speak out, well, you can produce postcards that you can send to your friends to get them worried about climate change, and these are the sort of things. But I thought it was interesting, the topics they've picked out, #SpeakOut has picked out, they've picked out, obviously, threats to the Arctic, threats to low-lying nations, the Maldives, I believe this is, extreme weather, wildfire risk there, large-scale singular events like collapse of ice sheets, more extreme weather. It's sort of, those are the 3 people focus on, and of course economists are worried about the aggregate impacts on the world economy. But the reason of concern that I think we are actually most concerned about is rather mysterious number 3, distribution of impacts. And what it means, what it's defined as in the IPCC report, is the risks and impacts that disproportionately affect particular groups due to uneven distribution of physical climate change hazards, exposure, or vulnerability. And this is the one I'm most concerned about because, back to the theme of this lecture, it's the one that has the most potential to impact on geopolitics. But to explain why I think other people are most concerned about it too, whatever they might say and whatever postcards they might send each other, I think this is the one which ultimately gets people anxious about climate change, is these emerging injustices in the climate signal we're seeing already. And the reason I think this, I can sort of sum it up with actually sort of 3 things. John Rawls, an American philosopher, disaster movies, and the People's Postcode Lottery. So these things are linked. John Rawls was an American philosopher who, in the early 70s, produced a theory of justice, which was based on the premise that you had to imagine organizing a just society was one in which you would deem it as just, even if you didn't know who you were going to be in that society. So he introduced the idea of a veil of ignorance, that you didn't know who you were going to be, so how would you want society to be organized without knowing which member of that society you were going to become? That was the sort of thought experiment. And it has various consequences of this. And one of the key consequences was it highlights, and it works because as a philosophy, because people liked it, people adopted it, a lot of people cite it. And one of the consequences of Rawlsian philosophy is a strong aversion to individuals losing out specific horrifically losing out relative to their neighbors. Nobody likes that prospect of maybe being suddenly much worse off than your neighbor. And which I think this relates to the way we react to disaster movies, is that the disaster that occurs in a disaster movie occurs to everybody. And people find this almost strangely reassuring. Yeah, it's the end of the world, but it happens to everybody. I think what was the one exception to this, by the way, which was very, very clever, Don't Look Up. Of course, they kept the ironies going all the way through that movie, and they had all the hyper-rich people went off in a spacecraft, frozen at the end. Sorry, I'm spoiling this. Spoiler alert here. But they kept up the fact that the unfairness continued, even all the way through to the end of the movie. Why do I think the People's Postcode Lottery isn't? Well, I get exercised about this kind of thing because, so it's not that relevant, but it does make me very angry. So the People's Postcode Lottery, I don't know if you follow this sort of thing, but it's designed that so here's lots of happy people in Altrincham who've all won 10 grand each because they played the People's Postcode Lottery. What it doesn't show you is the other people of Altrincham whose neighbours are all annoyingly smug. Okay, so the way the people, they're actually exploiting Rawlsian philosophy. They may not say this on their website, but what they're doing is they're frightening people into thinking you're going to be worse off than your neighbours if you don't buy a People's Postcode Lottery ticket. It's blackmail of the poor at the lowest level, and I cannot understand why it hasn't been banned. Anyway, the problem is with climate change, with what's happening is it's emerged already. We're seeing very uneven, even at relatively modest levels of warming, up to 2 degrees, we're seeing very uneven impacts of climate change on countries around the world. And we did some work in the build-up to the IPCC 1.5 degrees report, looking at the economic impact of 1.5 and 2 degrees of warming relative to where we were at, which is 1 degree of warming today. And this was work actually which Felix Pretis led in the economics department in Oxford. What I found was really interesting about this work was it was entirely empirical. He used empirical relationships between productivity and temperature in different countries around the world. And he managed to show that a very clear, geographically distinct pattern, hot countries lose out, cold countries do well, out of the climate change. And by and large, if you also look at, so you can see that it's primarily countries in the deep tropics, which are typically also countries that have not contributed a huge amount per head of population to climate change. They're the ones who are most impacted by climate change to date. And of course, if we go and look at the individual countries, at the top of the list, you've got Finland, Russia, and so on, doing relatively well out of modest levels of warming. And at the other end of the list, you've got Mauritania, Mali, and so on down at the bottom. Interesting, you can see United Arab Emirates there. That's, of course, because this is looking at the impacts of the warming on these countries, not the economic benefits of the things that cause the warming. So you may be slightly surprised to see the United Arab Emirates there, but you can sort of see why. And of course, because we've got these very uneven impacts of warming, that is compounded by the fact that we have equally uneven, even more uneven, contributions to warming. And the fact that the richest 1% of the world's population is responsible for the same emissions as, in consumption terms, is responsible for the same emissions as more than half the world's population. So that sort of extraordinary unevenness of both the causes of climate change and the impacts of climate change is something that one fears, if we just carry on as we are, is going to fuel ever more resentment and instability. And in fact, when the conversations at COPs are, in fact, I find remarkably civilized when you think about what's going on and what the negotiations are over. It's actually, it's often quite amazing how polite and as I say, civilized that the developing countries who are really being badly impacted by climate change are. Which is why, of course, I find this sort of mantra of many energy companies, since the last lecture, by the way, I had an interesting experience of going to CERA Week. You probably haven't heard of this. I'm sure you've all heard of COPs. But what you probably didn't know is 4 months after COP, there's an anti-COP, which happens in Houston, of course, and the fossil fuel industry gathers together and basically decides where to drill next and that sort of thing. And they like to invite academics along to talk to them. But there's a lot of this sort of stuff was being talked about. Oh yeah, we have to keep drilling, we have to keep producing because otherwise the world's poor will miss out on the wonders of fossil fuels. And of course, really, I mean, the people benefiting from continued use of fossil fuels are by and large not the world's poor. And of course, in closer to home, this is a very common mantra of outfits like Net Zero Watch, the group that's sort of taken over from the Global Warming Policy Foundation, and they're always sort of full of how green taxes and so on are going to hurt the poor. And of course, you need to be careful that climate measures don't hurt the poor, and it's something which we, in Britain, I think, need to put a lot more attention to. But the solution to that is obviously not to have any climate. Well, their solution is so you don't have any climate policies. I mean, no, you can design your climate policies so that they don't adversely affect the poor. And if you just decide, if you listen to Net Zero Watch and decide, well, it's just not worth having any climate policies because they might adversely affect the poor, you end up, with essentially climate inaction, which even, hard-headed folks like the US National Intelligence Assessment, consider that this is actually one of the highest risks they see to US security. So these are sort of military planners taking it very seriously. And it's interesting that the perception of insufficient contributions to emission reductions is at the top of their list of geopolitical risks in this report. So it's the idea that all those red countries in that map who are most adversely affected by climate change and by and large have the population which is down at the bottom of that shaped will sort of become increasingly resentful of the countries that are doing well out of climate change. So this is absolutely not, so worrying about geopolitics is absolutely not a reason for climate inaction. But at the same time, we have to worry about certain kinds of climate action. And the one I now want to talk about for the next part of this lecture is this idea of intervening explicitly in the climate to effectively turn down the sun in order to cool the planet. This is an idea which is out there. It's being discussed. It's being discussed more and more, actually. And the UK government has even seems over the past year or so to have sort of changed its mind and decided to actually start funding some research in this space. It's gone back a long way. Weather control was big in the 50s. I love the fact that back in the 1950s, you always put a tie on before you destroyed the world. It's like... but anyway, so let's just go through sort of these the ideas that are out there. One option is to enhance the reflectivity of the surface, and this is there is actually a research group in Cambridge that has got funding to go and pump water onto the surface of sea ice in order to have that water freeze and enhance the reflectivity, and so they're actually aiming to intervene to try and refreeze the Arctic. Yeah, okay, not a research group I'm a member of. There we are. But anyway, an interest. It's we do have active research programs in this space. Another idea is to increase the brightness of low clouds over the oceans, again to reflect away more sunlight. That's one of the interventions that we kind of incidentally have quite a lot of information on already, which we'll come back to in a minute. Number 3, increasing the reflectivity of the stratosphere by putting material into the stratosphere to reflect away sunlight. This is the sort of synthetic volcano idea. Finally, we get on to the more sort of if I was going to say far-fetched, or at least certainly expensive options like space-based mirrors or sunshades, and deliberately decreasing the amount of high-altitude cirrus. you're all familiar with contrails and the arguments that contrails may be contributing to global warming, but there is an argument that you could actually try and go sort of into a sort of anti-contrail. You could actually try and intervene to try and get rid of natural cirrus in order to try and reduce its warming effect. All of these ideas are out there. They've been out there for some time. We quite often see artists' impressions like this one. Can anybody spot what's wrong? Fortunately, it's an artist's impression, or some engineers would have got. That's right. Yeah, the sun's over there, guys. So okay. So whoever put that mirror up didn't really do anything. Anyway, but more seriously, there are options out there which we know would work, and the reason we know they work is because we have sort of accidental experiments going on. So this is a picture of the Pacific, cloud cover over the Pacific. And if you look carefully, particularly if you use a machine learning algorithm to spot them for you, you can spot all these tracks in the clouds, okay? You see them? And the purple is just highlighting the ship tracks. And these are the additional cloud that's generated as a result of the pollution that's coming out of the smokestacks of the engine exhausts of ships. And we are actually performing an experiment at the moment because just a couple of years ago, we introduced new low-sulfur standards for marine bunker fuel. So and we also had an interesting experiment where we had a global pandemic, and that also reduced shipping quite a lot. So the global pandemic was fortunately only temporary, but the marine bunker fuel rules are persisting. And so we're actually able to see the impact of a reduction in the pollution, in marine pollution on low clouds. So we're actually seeing some impact already of the, and in fact, I was just hearing last week, I think it's still under review, this paper, but colleagues in the US have actually think they can detect even a consequence of this in the temperature record. They're actually sort of seeing a little bit of, we've seen a couple of, as you all know, this past year has been a very warm one, and maybe some of that warming, I wouldn't push the boat out as to how much, but a little bit of that warming may have been contributed by the fact that we've cleaned up ship tracks. Yeah, that's a good thing. It was bad pollution over the ocean coming from this high sulfur fuel, but as a result, we've reduced the amount of bright low cloud in the bright low cloud over the oceans, which has the result of actually raising global temperatures. So the obvious implication is, well, wait a minute, maybe we could just put the sulfur back, or maybe put something back into the marine fuel that's not quite as nasty as sulfur, and brighten up those clouds again. So, yes, you could do that. I mean, this is the point here is that, that we do know that this kind of intervention is possible. And therefore, solar geoengineering could, if you implemented it, it could actually have an impact on peak warming. And this is the kind of scenario that people like to talk about, where you've got warming heading up. This is one of the figures from the 1.5 degrees report. And sort of imagine a scenario in which temperatures are heading towards 1.5 degrees, and that pink line is 1.5 degree line there. You're reducing emissions, you can't reduce them fast enough, so you realize you're going over 1.5 degrees. You deploy a sort of geoengineering scenario. You pump lots of, the scenario here is the stratospheric injection one. You pump lots of material into the stratosphere, and you reduce the incoming radiation by just the right amount to sort of shave the peak off the global temperatures. And this is sort of suggested as a good thing to do. And it's even actually, we've even got to the stage where people are saying, well, this is possible and cheap, and you can even do it right away. You can buy a bit of solar geoengineering. This is a company, Make Sunsets, that is releasing balloons into the stratosphere above America. The balloons sail up into the sky. They're clever. They put cameras on them so you can sort of see what your balloon is doing. That's the view from the balloon down over, I think it's California. It must be California, actually, because they tried to do this in Mexico, and Mexico promptly banned it. And this is the view of the balloon, and then you see it bursts, and that puff, that sort of grey cloud, you see you're falling away after it bursts. And that sort of slightly murky yellowish cloud, that's sulfur dioxide that's been included in this balloon, so that's now going out in the stratosphere, and they're saying, well, that sulfur dioxide will form a sulfate aerosol, is the argument there, because when you put that sort of gas into the stratosphere, that's what happens. This is going to cause some cooling. So they're saying, you can go to their website, and you can, for £9, you can offset the warming effect of 1 ton of carbon dioxide for 1 year. And then underneath this, they say, offsets 1 ton of carbon dioxide for 1 year. The average American generates 15 tons of carbon dioxide per year. If you've really been concentrating in these lectures, why is this misleading advertising? So can the average American, what you're clearly meant to do is multiply that by that and think, I can offset my carbon dioxide emissions for a mere £135 a year. Anybody want to comment on what's wrong with this logic? So it's only the 1 year, and how long does the temperature impact of your carbon dioxide emissions last? Forever. Yeah? Okay, so in fact, what it actually takes to neutralize the carbon dioxide, so suppose you were emitting 15 tons of carbon dioxide per year, you need £135 in year 1, 270 in year 2, and so on, £12,000 in year 90, and, okay, at some point you're going to stop emitting, but then it's like forever, yeah? That's the problem. That's the fundamental problem with this sort of approach. If you're going to try and compensate for the impact of carbon dioxide emissions by dumping stuff in the stratosphere, you're making an absolutely permanent commitment to keep doing it until you've actually taken the carbon dioxide back out of the atmosphere again, which of course is what happens in that scenario. I'll just go back to we'll come back onto it. Sorry. We'll come back to that scenario which I was talking about in a minute. But to be fair, I think Make Sunsets are if you go further down their websites, you can get a big discount if you take out a monthly subscription. So maybe that sort of makes the economics a bit better. But the point is, seriously though, particularly if it was done by a government or something as a sort of big scale program, cost is actually not the main issue with such a. It would be affordable if somebody was to decide to do it. But the real issue with it, and the reason it's so destabilizing, is because, of course, there's more to climate than just global average temperature. And this is an excuse for me to talk a little bit about climate physics again, and tell you why. So reflecting away sunlight, it can have a sort of equal and opposite effect on global temperature as increasing greenhouse gases, but it can't have an equal and opposite effect on the climate as a whole, because, of course, the climate as a whole is much more than just the global average temperature. So there are absolutely certain to be side effects of a program where you're modifying the climate by pumping material into the stratosphere to hold down surface temperatures. And that's when the arguments begin. And let me just sort of illustrate one of these side effects with this animation of this is global precipitation. This is precipitation around the world. And from NASA's iMerge satellite data set. And what you should find sort of impressive about this, just drawing your attention to about this this data set, is that you can see the diurnal cycle, the daily cycle of temperature in the tropics and so on. You can see how noisy it is and how apparently random it is. But if you sort of fuzz your eyes a bit, you'll notice the total amount of precipitation doesn't really change very much, despite the fact that in any particular location it's changing massively. So what's going on? And in fact, if we look over time, from 1980 to mid-2010s, you can see global average precipitation in this lower figure barely varied by more than plus or minus 2%, very flat. At the same time, the global average temperature was actually going up quite a lot. And global average temperature went up by about 0.5 degree over that period. Precipitation flatlined. And and not only flatline, but it didn't even wander about. It seems to be sort of kept at a particular level. And it's really interesting why. Why it is that precipitation, global precipitation, is kept so constant. And the answer is, it's an interesting piece of physics, in that when a cloud forms and rain forms in the cloud and rains out, it releases energy into the troposphere, into the upper troposphere, and warms it up. So if you all know that air gets colder with height, but when a thunderstorm occurs and you have rain, air gets less cold with height. So let me get this right. So colder, warmer. I'm trying to get that. So a thunderstorm occurs, and the temperature is pushed up in the upper troposphere, and then, of course, because it's falling off less rapidly with height, the atmosphere is stabler because you've got warmer air over colder air, and that suppresses convection again until the air in the upper troposphere has cooled down again. So it's warmed up by the convection, and then it gradually cools down, and then you get the next event goes off. So, like many processes, rainfall, the overall, what we call the global hydrological cycle, is controlled. The rate of rainfall is controlled by the slowest step in this sequence. Chemical reactions are like this as well. It's always the slowest step in a reaction that determines how fast the whole reaction takes place. And the formation of a cloud, the formation of rain, and so on, that's all very quick. But this cooling off of the atmosphere after the rain has formed, that's what takes time. And that's what determines the total amount of rainfall that happens in the world, is the ability of the atmosphere to get rid of the energy that's being released by the rainfall. We understand this. This is the basic sort of physics of how rainfall is controlled. And that's why you saw that's why we see a very constant amount of rain here, and why you saw that sort of very constant rainfall around the world in the animation. But then you might be puzzled because you think, well, global temperature's going up, and a warmer atmosphere should be able to get rid of energy faster because it's warmer, it's been radiating more, and therefore why are we not seeing more rain? Well, the answer lies in what's driving the warming, of course. Because if we increase, and this is a figure from a kind of very old paper, but the point still stands, that shows the warming in lots of different climate models resulting from an increase in carbon dioxide, doubling in this particular case, against the precipitation change in the vertical. And you'll notice they fall on more or less a straight line, but it doesn't go through the origin. So if you were to double carbon dioxide in a climate model, and we do see this in climate models when you do this, you actually immediately reduce the ability of the atmosphere to get rid of the energy released by rainfall. Yeah, because you're making it more opaque, so it can't get rid of that energy as efficiently. Remembering those of you at last year's lectures can remember those pretty colored balls which told you about how the atmosphere got rid of its energy. And then, of course, it warms up, and you go off in this direction, and that's the temperature-dependent effect. But if you were to compensate for the temperature-dependent effect, come back down this red line, you don't get back to where you started. You've got all that carbon dioxide, which has dried out the planet. So if you were to compensate for the temperature-dependent effect by pumping material into the stratosphere, your sort of artificial volcano idea, you end up down here. So you swapped global warming for global drying. And you can't get around this. This red line does not go through zero, so there's no way back to zero. And at a regional level, it's even more obvious. And this is a piece of work done, but we had a visiting student, Kate Rickey, who's gone on to actually become one of the world's leading experts in solar geoengineering. And she, in a really nice study, showed how the regional impacts of geoengineering were different over India and China. We just chose those as two big blocks of land, but also because, of course, they're powerful players. And if you look, just focus on the 2070s results, this is a scenario in which there's a discussion about how much geoengineering do we want. And the circle shows pre-industrial climate, sort of within one standard era of pre-industrial temperature and pre-industrial precipitation in these individual regions. And you'll notice that, if we go for more geoengineering, China's happy, they're back inside the circle, but India's out of the circle. India's been driven to a climate that's different from its pre-industrial. And of course, if you go for less geoengineering, then India's happy, they're inside the circle, but China's not. So this kind of regional disparities are inevitable from a geoengineering plan. And it's taken me 10 minutes to explain to you why, but everybody can understand this. And so, the governments of India and China may be very rational, and they may be able to sort it out and agree on that. But, there are others. Here we are. Thanks to John Berman for pointing this out. This is James Delingpole. Anyone who still believes that the weather is not being deliberately engineered to create food shortages deserves all the food price inflation and starvation we will inevitably get. Now, never mind James Delingpole is saying this, but, 135,000 people are reading it. Lots of them are liking it. Even with what we're doing today, I always find it intriguing how the conspiracy theorists are convinced the government's very incompetent, but then they're convinced the government's doing something really clever. How? Anyway, never mind. But the point is, there's enough justification. If the government were actually doing this, you can imagine the conspiracy theorists would be having a field day. As I say, effective solar geoengineering, which actually sort of does enough to make a difference, is uniquely destabilising. Unlike removing carbon dioxide from the atmosphere, which does have a sort of compensating effect, putting carbon dioxide into the atmosphere, solar geoengineering can only be done on a global scale. There's only one climate view to intervene in, and it can't compensate fully for the impact of the carbon dioxide emissions. So, by the way, I think one thing I do feel very strongly about is that reports like this one, again, it's a long time ago now, but it rather set off the way of thinking. For 10 years, people thought of carbon dioxide removal and solar radiation modification as sort of two parts of the same thing. They're not. They're fundamentally different. One is actually compensating for the impact of putting CO2 into the atmosphere. The other one is this sort of sticking plaster. And when we come back to this scenario, if you look at the sort of, this was included in the 1.5 degrees report as a sort of suggestion of how solar geoengineering could be relatively harmless. But if you look at what harmless implies, you realize that you're actually deploying the solar geoengineering after you've already reduced emissions by almost half, and you're only a couple of decades off net zero. Why on earth would you at that point suddenly head off on a complete tangent and start deploying geoengineering? And of course, when the impact of the geoengineering is actually sort of kind of within the uncertainty in the response anyway. So fortunately, for now, there is a global moratorium in place. Back in 2010, in the Convention on Biodiversity, they agreed that there would be, the governments would ensure that no climate-related geoengineering activities that may affect biodiversity, which means them all, may take place until, there is a sort of get out there until there's an adequate scientific basis on which to justify such actions and appropriate consideration of the associated risks. So it's a moratorium for now. But most people agree that solar geoengineering could work. There's no really argument over that. But it's the geopolitical implications of solar geoengineering that really frighten people, and I think deserve when people are sort of talking about deployment, there's often, or talking about sort of research programs in this, they say, well, don't worry, we'll have a UN committee that'll manage it, or, and really, we don't really do that sort of thing very well. Anyway, to get on to, just to wrap up, I think to be fair, I think solar geoengineering is a particularly destabilizing measure, but I think to be fair, many climate policies have the potential to be destabilizing, and we do need to think about this. Because as I say, I think we do need to think about, the trade-offs between we need to stop the warming as soon as, we keep hearing we need to stop the warming as soon as possible. Is that quite correct? Are there measures that would actually be would be so destabilizing that it might even be worth accepting a couple of tenths of a degree more warming to avoid having to take those measures. I think solar geoengineering definitely fits into that category, but there may be other ones as well. And I think we do need to think about the implications of over-precipitous emission reductions in that category as well. What you might call the social geoengineering that would be required to achieve some of the more ambitious demand reduction scenarios that people are very fond of pointing to as the way they'd like us to solve climate change. I mean, at COP28, we had lots of people enthusiastically saying, we've got to phase out fossil fuels as fast as possible, but not, I think, recognizing that trying to achieve our climate goals by phasing out fossil fuels means phasing them out completely in the next 20 or 30 years, and that in itself carries risks. If we look at these scenarios, so this is 4 scenarios, all of which achieve 1.5 degrees, and what I'm showing you here is energy use, not emissions, but energy use in these scenarios from different sources. The dark green is conventional fossil fuel energy generation. And so you can see in 2 of these scenarios, we effectively phase out conventional fossil energy generation. The other 2, we reduce it, but it doesn't get phased out entirely. So what does that entail, that sort of fossil phase-out scenario? Well, in one class of these scenarios, it means that means this decade, 30% reduction in final energy demand per head of population. So, I mean, no government has any appetite whatsoever for that sort of, and whenever governments have tried to reduce demand like that, the result has been pretty explosive. I mean, you remember Macron back in 2018, for example. And then the other category actually involve amazing amounts of bioenergy production in the second half of this century, which we perhaps come into. So this is what worries me with some climate policies. It makes it a bit sort of too easy to come up with this kind of thing. And okay, I'm hoping this particular demonstrator is a minority, but the fact that that's out there and that it's increasingly entering the UK political discussion, I think is worrying. And I think the proponents of climate action, of which I'm absolutely one, I think need to look at what we're advocating for and weigh up, what are the implications of climate policies on different political people of different political persuasions and people in different social groups in order to make sure that we prioritize inclusive climate policies that don't divide people. I think at the moment, actually, particularly in the run-up to this election, you're going to see, I think, both sides seem to be quite keen on making climate an issue in the election in a pretty unhelpful way, because if the Conservatives are seeing it as climate's just this woke issue for the urban classes, that could really contaminate the conversation about it for decades. But I think we need to look at the kind of policies that Labour's putting forward as well, and ask yourself, are they really designing them with inclusion in mind? One particular policy that we'll be talking about in the next in the next lecture and indeed next year, the idea that you ban new extraction of fossil fuels. It doesn't have an obvious impact on emissions, makes it very easy to sort of polarize the debate around it. And it makes it, very much on those communities that are immediately affected by a fossil fuel extraction ban. It's a way of dividing people up, and it seems to me an unnecessarily divisive, for its minimal impact on the actual problem, it seems to be an unnecessarily divisive policy. Plenty of people disagree with me on this, I should stress. Anyway, so to sum up, I worry overwhelmingly about the geopolitical risks of climate change. I think it's the impact of climate change on us and the way we interact with each other that are the biggest risks that are in this. And one of them, one option of just sort of not doing anything because you're worried about the geopolitical consequences or the political consequences, that will eventually just stoke resentment. Probably not just eventually; it's already stoking resentment. So this is absolutely not an argument for non-policy on climate because you're worried about offending people. Quick fixes, particularly solar geoengineering, is likely even worse in terms of stoking perceived injustices and perceived anger about this issue. But we have to apply the same lens to all policies. We have to ask ourselves, when particularly draconian policies, which would be required if you wanted to try and address climate change, focusing heavily on demand, which is the way a lot of the climate mitigation policy community are going at the moment. They're saying, well, the technologies aren't being deployed fast enough. The only option left is to really focus on demand and reduce the amount of consumption around the world. That has the potential to become really, really divisive. And I think we need to ask ourselves, are these rapid demand reduction scenarios worth the likely social and political impacts that they may have? And the conversation will continue, and we'll come back to it. But anyway, so that sums up this one. But in the next, on a much more positive note, so sorry if this has been a rather sort of negative and gloomy lecture, but in the final lecture of this series, we will try and talk about sort of what can be done, what on the positive side, what can be done to design inclusive climate policies to avoid these kind of geopolitical tensions. Well, thank you.
You can imagine. First, perhaps the question of, you said that there is a lack of consensus among countries, and there is the question about actually the potential implication of unilateral deployment of solar engineering techniques. What could be the potential implications of that?
Well, it's already happening. Those guys in California are letting off these balloons. Unfortunately, they're only letting off a few, and I assume once they get to any scale, they'll just get banned, and that'll be the end of that. But they've made plenty of money. If you look at their website, they've got lots of investors piling in, and clever guys in the short term. I'm not sure that's very good. But yeah, the point is that even a wealthy private individual could start messing around with the Earth's climate. The difficulty, of course, is you can't do it secretly. So it would be pretty much impossible to start geoengineering without people knowing that you were doing it. And as a result, the conspiracy theorists, but even non-conspiracy theorists, even perfectly sensible people, would immediately start to say, well, wait a minute, they're doing this program, and I've just got this mega drought, which is killing all my relatives and so on. Maybe this is related, and you'd have some justification for that. And that's the problem. And that's when potentially the wars start.
And interestingly, are they actually computing the carbon footprint to make the balloons? Because this has...
I wouldn't want to start getting into those sort of arguments. Maybe they have, but
or even just other forms of solar engineering techniques. That's quite an interesting...
No, but there is no question that stratospheric aerosol injection, or marine cloud brightening for that matter, could be done. It would be relatively cheap. That's the sort of scary part of it. Is it's affordable, but it definitely has side effects, and it has comprehensible side effects. It has side effects that everybody would understand, and therefore everybody would, feel it's impossible for a government to get away with saying we're doing this, but don't worry, it's not having any adverse impacts anywhere in the world, because somebody would blame them for the weather.
Another question is actually related, is about, to avoid conflict. It seems that transparency and accountability is key here, and it has to be ensured. How can we make sure of this, in the sense that there is a lack of awareness of all these techniques and so on?
I know that this is, there's a foundation, I'm blanking on the name, Janos Pastor is the head of it, where they talk a lot about this sort of accountability and inclusion of different countries and different perspectives and so on in discussions about geoengineering. I think that's hopeless, to be honest. Doesn't matter how transparent you are, you're still going to get blamed. In fact, arguably, the more transparent you are, the more you're going to get blamed for the weather, regardless of whether it's true or not. you saw the tweet. I mean, it's and there's enough of a reasonable narrative there for there to be that risk. And inevitably, if this actually happens on any scale, it will be with the blessing of the big military powers. So, I mean, for this to be done on any scale, it's either done by the US or China, or done by somebody else with the blessing of the US or China, and probably both. I mean, you'd need, and so therefore, the US or China, or both, would be held responsible by the rest of the world for this program that they are allowing to happen. That's where it gets frightening.
All right, questions from the audience, yeah? Yeah?
I thought one...
Sorry.
Thank you. So one interesting idea that James Lovelock had of a low-cost way to reduce global warming would be to force all the airlines to run the intercontinental flights during the day instead of at night, so that the vapour would have a dimming effect. How would that possibly work or not work in the context of solar geoengineering?
Yeah, I mean, it doesn't. There are. I mean, the conversation around this is actually more in the other direction, whether we should sort of avoid flying planes at night because that has a disproportionate warming effect. Okay, it's the same. So it's the same thing. The net impact of all the air travel would still be causing warming. You'd just be causing slightly less warming if you shifted them to the day. If you actually want to get a net cooling effect, you've got to start chucking additives into the jet fuel, and so as to create sulfur dioxide and hence subsequently sulfate aerosol clouds. So you've got to actually do something, and I think that's where it gets destabilizing, is because if you're just saying, well, I'm just going to fly my planes at a different, I'm going to change my plane planning, my flight track planning to reduce the amount of warming my airline causes, that sounds like the kind of thing people aren't going to get that upset about. That sounds like a good thing to do. But if you say, I'm actually going to start actively intervening to cool the planet through adding this additives, that's when you're going to start getting blamed for all the side effects.
Yep.
Thank you for a very interesting talk. I'm curious how you respond to what I felt is kind of an increasing rhetorical push from a lot of energy companies arguing, we're getting to net zero, but we're still going to need fossil fuels, 50, 100 years from now, which it sounds like based on your talk you do agree with, but maybe to a different extent than a Total or something like that. I don't know. I'm just curious how you kind of respond to that rhetorical shift.
I would agree with them. We will still be using fossil fuels in 100 years' time. The question is whether those fossil fuels will be causing global warming. They know how to stop the fossil fuels they sell from causing global warming. They're just not doing it. So that's my answer, is yes, if you think we're going to have to carry on using these things, then you should be stopping them causing global warming. That means disposing of the carbon dioxide that they generate back underground. They say this will happen, but that somebody else will pay for it. That's the argument. So my response to them is, if you want to keep selling your stuff, what's your plan for stopping it causing global warming? And by the way, one of the things I did learn about at CERAWeek, one fossil fuel company in the world does have a plan and has a commitment and are putting money behind it to stop the fuels they sell from causing global warming by 2050. They're going to be putting a ton of carbon dioxide back into the ground for every ton generated by the fuels they sell by 2050. They're putting about $1 billion into the first plants of this kind in Texas to actually capture carbon dioxide out of the atmosphere to start putting it back underground. That company, this is all public, that company is Occidental Petroleum. It also happens to be the only fossil fuel company in the world whose chief executive is a woman. Observation.
Someone is asking about nuclear energy, no longer part of those 4 projections to phase out fossil fuel use and achieve 1.5 degrees of warming. Is there a fear of nuclear energy sort of justified?
Yeah, I did actually think of having a 4th topic in this on the nuclear option, as it were, and because, of course, that's another one where you've got to weigh up the geopolitical implications of a nuclear future versus the benefits to the climate. There would undoubtedly be benefits to the climate to shifting our energy systems rapidly to nuclear. But of course, there are other consequences there. By and large, at the moment, where I stand on that is the costs of there's cheaper ways of getting to where we need to go, and in particular, fossil energy getting rid of the CO2 is actually competitive. It's significantly cheaper actually than nuclear energy at the moment. So nuclear energy has got a lot of work to do to actually even become competitive with, as it were, safe fossil energy. Obviously, fossil energy dumping the CO2 in the atmosphere is the cheapest of them all, but that's a bad idea. We've kind of agreed that. But even if you get rid of the CO2, capture it and put it back underground, you're still cheaper than nuclear energy. And so that's why I think, for example, the amount of money the UK is spending on Hinkley Point is ridiculous. There you are.
Questions? Oh, good. Thank you.
I'm sorry, I didn't quite understand the fact that precipitation is carrying on at a constant rate, but temperature is going up. What kind of effect is that going to have on food production?
Okay. So yes, sorry. I appreciate the opportunity to go back into that because that was the bit of physics in this lecture. The thing is that carbon dioxide is going up at the same time the temperature is going up, and the level of carbon dioxide in the atmosphere has a drying effect, a direct drying effect. Yeah. Whereas temperature is going up, that has a moistening effect because and so at the moment these two things are competing with each other. If you eliminated the point I was making was if you eliminated the warming effect of the CO2 by some sort of sun shield, you would still get the drying effect of the CO2. So you would then swap that constant precipitation with a steady reduction in precipitation, which so farmers are not going to be happy. Well, farmers are never happy. I mean, that's a golden rule. But yes, I mean, we are seeing impacts of the climate changes we're already getting on food production, and there are side effects of geoengineering on food production as well. I mean, we could. There's entire conferences devoted to quantifying the side effects of geoengineering. The argument's always made, yes, but it would be much worse to just let the climate warm up. And you can make that argument, but the problem is, I don't think that argument will work for the people who feel they're being adversely affected by the global geoengineering program. Telling them, oh, but you'd be much worse off if we weren't doing it, probably won't work for people. And that's why I see this as this uniquely destabilising idea.
I think we might be able to take I'm just going to take one from Slido and then I'll leave it to the floor for. In a global interconnected system, are government thinking about the knock on social and geopolitical effects of climate change, mass migration, refugee crisis, etc., wars, food shortages, etc.? Do you think there is enough?
Well, I hope they are. In fact, I hear there's some people here from the FCDOs, so hopefully they're thinking about this, because yes, there's lots to think about. We live in a highly interconnected world, and these are the impacts that we will become most. We also live in a corner of the world where we can probably insulate ourselves from the worst effects of climate change. This is a part of the world where, we'll have a bit more flooding and that sort of thing, but it's not, it's not the same as the impacts that are likely to happen in, say, North Africa or the Asian subcontinent and the Indian subcontinent. So I think that's where this really fuels this geopolitical tension, because if you have rich countries that have overwhelmingly caused the problem, putting up barriers to stop people moving from poor countries where these countries have literally become uninhabitable because of warming. As you see increasing regions of the world, we're seeing increasing regions of the world becoming, experiencing temperatures where people simply cannot safely work outdoors. If those, we're seeing increasing incidents of this, then that's going to be difficult, because you're going to be telling people, sorry, we changed the climate, you can't live where you're living, but you can't come to here either. I can see that. That could end badly.
More questions? I think we have the gentleman over there. Thank you.
Hi. Just a thought. I mean, in terms of, sort of mitigating resentment, the fact that there's 1% of the global population contributing 66% of emissions, I think that's about 2,500 people in the world, according to the Forbes rich list or something. But can't we just focus on reducing their emissions? As a very
The
small number
1%.
of people. Yeah.
I mean, if the 1% richest people in the world did lots of slightly different things, the world would be a very different place. But we don't. You know, this is one of the challenges we face. Is we can't control these people, and probably we are. I mean, it's the 1% I'm talking about here. So it's a lot of people. I mean, it's probably much of the population of London probably is in that 1%. So you know, it's important to recognise this is not a few plutocrats. This is a large chunk of the world population. But yes, I think we do need to think about climate solutions. We need to look at climate solutions to make sure that they're, you know, primarily affecting the emissions of the global rich. So sort of back to fixing fossil fuels, for example, I wouldn't turn around to Mozambique, who's just discovered oil and gas, to say you have to put all the CO2 from your oil and gas back in the ground. I mean, you know, that's we should do that in Britain first. You know, we could do that in Britain. We could stop the oil and gas we produce in Britain from causing global warming relatively quickly. In fact, I think I've said this fact before, but it's worth remembering. For the amount of money we were paying for gas last year, you could have captured every single molecule of carbon dioxide that gas generated back out of the atmosphere, put it back under the North Sea, so all of the natural gas use in the UK would have caused no global warming whatsoever, and you could have done that twice over with the amount we were paying for natural gas last year. Now, admittedly, we were paying a lot for natural gas last year. That was even with the government price cap, okay? But that puts it in perspective. This is a fixable problem. But you've got somebody, and basically some government, has to have the guts to stand up and say, no, okay, this is going to have to change. And we're going to talk about this in the next...
Shall we take another one? Shall we push?
I'd love to hear this question, because it's obviously...
One last question, please.
How about something like those that produce an item or an energy or a gas are responsible for the disposal of the effect in the first place? So the Qataris may be supplying a great chunk of the gas we're burning out of Milford Haven and wherever, but they should be responsible for doing the equation that takes the CO2 produced from their product out of it. Same as if I was to buy a car, the disposal of the car at the end of the day is an issue as well. How about that?
That is a genius idea, and I commend you to Allen, Frame and Mason 2009, where we suggested the case for mandatory CO2 sequestration. And I can also, so we called it the carbon take-back obligation, or that's its new name, and ultimately I firmly believe this is actually how we're going to solve the problem. It's going to have to become a condition, a licensing condition. If you want to dig it up, you've got to put it back. And it's that simple. By 2050, nobody should be allowed to sell stuff that causes global warming. So if you want to sell fossil fuels, you've got to get rid of the CO2. Either your own CO2 or somebody, or go capture it back out of the atmosphere. I don't care, as long as you can prove that it's been got rid of. That's the solution. And what was frustrating at Zero Week in Houston was the number of people who I said this to, and they all said, yeah, that's obvious. We know that's going to happen. Yeah? They said, yeah, of course. And when it's compulsory, we'll do it. And I said, would you say that in public? And they said, no.
Well, thank you very much for this fantastic lecture for this morning. Thank you.